start by looking at trigonometric ratios. Now, what is a trigonometric ratio? Essentially, a trigonometric ratio expresses the ratio of two sides of a right angle triangle. A trigonometric ratio will express the ratio of what? Two sides of a right angle triangle. So let's look at the possibilities we can have. We have opposite, adjacent, and hypotenuse. So we can have ratios that, so I'm going to use this because sometimes when we talk of trigonometric ratios, students seem to see it as one abstract thing. So I've used O for opposite, A for adjacent, and H for hypotenuse. Let me now show you how this can stretch into the concept you'll see later in further maths called permutation and combination. What are the possible number of occurrences you can have? Now, let's look at this. You can have O with A, you can have O with H, you can have A with H. I see that. Now, you can also flip this to become A with O, H with O, and what? H with A. This iteration already suggests to me that there are 6 types of trigonometric ratios. Now, with the way I've done it, it means this will be what? Ratio would normally talk about what? Numerator over denominator. So a ratio will usually express the numerator over the denominator. So with what you've seen, there are 6 possible outcomes when we talk about what? Ratios. Now, numerator over denominator, 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 numerator over denominator. So let me give you all the types and show you what is going to happen. From your secondary school, early secondary school, there's something you were taught. As a student of mathematics, you are expected to remember these 3 basic types of ratios. This S stands for sine, this one stands for cosine, and this stands for what? Tangent. Sine, cosine, and what? Tangent. Remember that the ratio expresses the relationship. And in this context, our trigonometric ratios will express the ratio of 2 known sides of a right angle triangle, usually the reference triangle used to explain this model. All right. So we look at this. Sine is this, cosine is this, adjacent is this. Now, for me, I usually choose to write it this way. I write O over H, A over H, and this is what? O over A, where O stands for opposite, A stands for adjacent, and H will stand for what? Hypotenuse. All right, so with that settled, these are the basic ones you have, but you discover that I also have another 3. I say that. So if this is O over A, if I flip it, what I'm going to get is what is called the cotangent. And how do I express the cotangent? I will express cotangent as what? A over O. I'm just handling it as if I've never done trigonometry. I've never done trigonometry before, because if you have done permutation, you discover that the number of possible outcomes there would have been 6. But that's an Easter egg for a topic you will see later. But just to help you see that sometimes you must understand that when it comes to this matter of mathematics, the ideas are connected. Your task is to try to see this connection. Now, look at this one. Cosine will be seconds. Seconds. So this is the reciprocal of this. You know, because remember that when we're treating reciprocal, I told you that what reciprocal does essentially is to turn. So the reciprocal of this is what? Second. So it will turn this. I now have what? H over A. So secant will be this. Now let's come to sine. The reciprocal of sine is called cosecant. And that will give me what? H over O. So this gives you the illustration of the 6 types of trigonometric ratios you have. In mathematics, we usually limit it to just 3, but in further mathematics, you must know that there are 6 types of what? Trigonometric ratios. All right, so I'll leave it at that because I will also come back later to drive these ideas further, but this is more or less like a descriptive class to help you see in perspective what's happening in this realm. All right, so we're done with that. So I'm going to give you a summary. Let me give you something like a summary. We have sine. So we generally call it sine theta. Or like in this context, okay, let's draw the triangle first so that we have a reference to what we are doing. O, A, H. So we have what is called sine x. Sine x will be equal to what? O over H. Remember, this is 90 degrees. This 90 degrees is important because that's what tells us what to do. Now, we have what is called cosine or cos x. Short form for cosine is what? Cos. And that is called adjacent over hypotenuse. We have what is called tan x. And that is called opposite over what? Adjacent. Now, we come to the big one. Now, we have what is called cosec. Cosec x. And that will be equal to what? Hypotenuse over opposite, which is equal to 1 over sine x. We come to the next, which is called secant or sec x, which is hypotenuse over adjacent. And that is 1 over what? Cos x. We come to the last one, which is called cot. The short form of cotan is cot. Cot x, and that will be what? Adjacent over opposite. And that is 1 over tan x. So that is what we should know about trigonometric ratios. So pause.